All right, hello and welcome to Chapter 2. No longer Chapter 1, but Chapter 2. In Chapter 2, we're going to be doing a whole lot of solving, right? It is a lots and lots of solving. Lots and lots and lots of solving is what we're going to do here. In 2.1, however, we want to just make sure we're going to review two things. You've seen them before, but we want to make sure everybody's understanding them before we move on. That is, like today, you're going to calculate square roots, you're going to approximate non-perfect squares, and you're going to classify numbers, okay? So this first video today is going to focus on these two things, and then we have a couple of other things on the Google Classroom for you as soon as you're ready to move on. First up, though, we've got lots of key vocabulary here today. Things to add to your vocabulary list. So it would probably be a good idea to pause right now and add these to your key vocabulary in your algebra folder. And I will, let's just kind of go over these things briefly. You've got rational numbers. A rational number is any number that can be written as a fraction. So, for example, 4 can be written as a fraction because it's 4 over 1, right? 3.2 can be written as a fraction because 3.2, that 0.2 is like 2/10, which is the same thing as 1/4 or 1/5. So we have 3 and 1/5, right? So we can write that as a fraction. Therefore, this is a rational number. An irrational number, on the other hand, is any number that cannot be written as a fraction. So its decimal is never ending. A couple of good examples of that would be pi, right? We know that pi is 3.1415926, blah, 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 blah. That's going to keep on going for a long time. It never ends. Because the decimal never ends, the fraction cannot be turned in, or you cannot turn it into a fraction. Some other examples would be like the square root of 5. That's an irrational number. It's 2.1 something, 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 something. Interestingly enough, these type of things where it's 0.3 repeating, those are rational, right? This is actually a rational number because you can make that 2 1/3. So when they have a repeating thing, that makes it rational. When it's not repeating anything, any decimals, then it's a irrational number, okay? You've got your whole numbers. That's any positive non-fraction number. So 2 is a great example of a whole number. Same with 5 and 100, right? 100 is a great whole number. Any positive number that is not a fraction is considered a whole number. And then finally, you've got the integers, and that's just any non-fraction number. So 2 makes a great integer, but also -4 makes a good integer. Notice that -4 cannot be whole because it's negative, right? Wholes are positive numbers only. Integers, not so much. And then finally, the last of our new vocabulary, a perfect square is a number that has an integer value as a square root. Really quickly, the square root of 4, which is 2, that's a perfect square. If you want a quick list of perfect squares, right? 1, 4, 9, 16, 25. Those are like the first 5 perfect squares. And we'll talk more about what a perfect square means a little bit later. So the square root of a number, if b squared equals a, then that means that b is the square root of a. For example, to throw some numbers in there, 4 squared equals 16, then that means that 16 is the square root. There's an announcement, hold on. I don't even know if you guys can hear that or not, but there's a lockdown procedure going on. It's not a real one. If it was a real one, I'd be screaming like a girl and leaving the room. So, well, that's a scary voice. You guys can't hear that, but there was like a robot saying lockdown on the thing. That's kind of freaky. I kind of feel like a robot's going to attack me now, and I'm a little bit scared. But we'll move on. We'll get through it. Don't worry. Because I'm not worried, obviously. So, the square root, where was I? The 4 is the square root of 16, right? then b is the square root of a. 4 squared equals 16. That means that 4 is the square root of 16. Okay. Basically, when we're looking at this this thing right here, this, by the way, is called the radicand. I don't think you ever really need to know that, but it's kind of fun. Whatever number is beneath that, you're looking to see what number times itself equals 16, right? Because 4 times 4 is 16. So square root of 16 is 4. 4 times 4 is 16. So that's what we're looking at here. So just a couple of quick examples, right? If we have plus or minus root 36, plus or minus meaning positive or negative, this is plus or minus what number times itself equals 36? 6. Or the square root of 49, what number times itself equals 49? 7. Or if we were to say have negative square root of 4, what number times itself equals 4? 2. But because there's a negative out in front, it's negative 2. So that's our square roots. Finally, the last thing here, we're going to approximate a non-perfect square. So non-perfect square, we said earlier that like root 25 is a perfect square because it has a whole number or integer as its value. Okay, so square root of 25, we have 5 times 5, that equals 25. But square root of 24, now that's different. I don't know what the square root of 24 is. I know that it's smaller than 5, but there is no whole number that makes 24 because 4 times 4 is 16 and 5 times 5 is 25. So there is no whole number, which means that square root of 24 is a number in between 4 and 5. It's probably approximately 4.9-ish because it's really close to the square root of 25. So our problem here says the top of a folding table is a square. The whole area is 945 square inches. Okay, so approximate the side length of the tabletop to the nearest inch. Notice that it says approximate. Okay, if we were to make a list of perfect squares, which I will for you, you don't necessarily have to have these ones memorized, but you know, couldn't hurt you. So 28 squared is 784, 29 squared is 841, 30 squared is 900, 31 squared is 961, and 32 squared is 1024. If we were trying to approximate this value, we're going to need to know where it kind of falls within the squares. 945 is going to put us right in between there. So it's bigger than 30, but it's smaller than 31. So the square root of 945 is bigger than 30, but smaller than 35. It's kind of right in the middle, right? Which means that this is about 30.5, right? And these wavy lines here, they mean approximately. They don't mean equals, they mean they're approximately. So square root of 945. Now later in the year, we're going to learn an exact way to calculate this, a way to simplify it, I should say. But for now, we're just approximating it to get it to be something close. Okay. So I'm going to have you guys do a couple more of these. I've got some other instructions for you about classifying numbers, which you will do next. And that's it.